And the core technology behind Cintoo Cloud is this capacity we have to turn a point cloud into a high-resolution 3D mesh. We believe the good foundation for a good digital twin is reality capture. So this point cloud to mesh transformation will be done prior to the upload. So everything uploaded to the cloud will be 10 to 20 times smaller in size than the source point cloud. You will see the surface that has been captured by your laser beam. The inverse transformation, mesh to point cloud, so that you can retrieve either E57, RCP, or CS files to feed your Revit or Navisworks or AutoCAD platforms. Everything collaboration and sharing for your laser scan data. Yeah, so my name is Dominique Pouliquen. I'm CEO of Cintoo and one of the co-founders. Before that, I used to be a product manager for Recap at Autodesk. So I've been there in San Francisco for many years. Now I moved to the East Coast for this new business. So the way we position Cintoo today is really at the convergence of digital twins and reality capture. Why is that? Because we are all familiar with digital twins, right? Digital twins, we believe the good foundation for a good digital twin is reality capture. And we believe that reality capture is even the element 1 or the element 0 of the reality capture, being the way you capture the as-built conditions, but also the element 1 of a good digital twin, because this is the way you will update your digital twin. And of course, by digital twin, I include everything around Industry 4.0, but also BIM and construction. So the pain point we've been facing, and that was the case already with Autodesk Recap, is what do I do with this fucking point cloud, okay? So the point cloud is so big that this is a very desktop-centric workflow until now, which creates silos within companies, but also silos between companies and contractors. And those point clouds are made for experts only, okay? So this is why we develop Cintoo Cloud. Cintoo Cloud is a platform that will make your laser scan data fully cloud compatible. And by making it cloud compatible, we'll make it shareable, distributable. We can enrich the data with annotations, of course, measurements, but also by making it cloud compatible, we can connect the as-built conditions to various BIM and digital twin workflows, okay? So Cintoo Cloud runs on Amazon, on Azure exclusively. You can even select the data center where your data will be hosted. If you want your data to stay in the US, you can do that. Or if you want your data to stay in France or the UK, you can also do that. It's also a very secure platform. We're SOC 2 Type 2 compliant, so we are at the highest level of cybersecurity for a SaaS platform. And the core technology behind Cintoo Cloud is this capacity we have to turn a point cloud into a high-resolution 3D mesh. So yeah, this is a technology that has been developed by a lab in France for about 10 years now, 10, 15 years. So we will take each scan coming from a static scanner, we'll turn it into a very high-resolution mesh. And by doing this point cloud to mesh transformation, there will be 3 major impacts. The first one is that the data will be compressed in a ratio of 10 to 20 times. So this point cloud to mesh transformation will be done prior to the upload. So everything uploaded to the cloud will be mesh-based first, and will be 10 to 20 times smaller in size than the source point cloud, without any loss of point cloud accuracy or density. This is very important to know. There is no compromise on density and accuracy with this process. The second interesting aspect of that, this mesh we will be able to stream it very fast in a web browser with no plugin to install. So people would call us the Netflix for 3D data, because we can stream very high resolution 3D meshes very fast in a web browser. Hopefully you will be able to see that in my live demo. Last but not least, we make the data much easier. We make it much easier to interpret Okay, the pain point we've been addressing for many years at Autodesk Recap, say, very few people will be able to use Recap be able to interpret a point cloud. Okay, now with this kind of mesh-based technology, your laser scan data look like a video game. So you can navigate much easier. Navigation is easier. Interpretation is made easier as well. Last but not least, we can do the inverse transformation. So there is no loss of information during this process. So we can go back from the mesh back to the source point cloud and retrieve your data as a RCP or E57 being structured or unified. Okay, so then we can use this technology not only to view and share and collaborate, but we can also use this technology to distribute your data via the cloud in a point cloud format. Why do we need a point cloud at the end of the day? Because in Revit and Navisworks, you need a RCP file. Okay? So let me show you this quick video. So all starts by capturing the as-built conditions. So we are very familiar with that. Okay, works for all kinds of spaces, being factories, oil and gas stuff, or a construction site. And this is our core technology. We will turn your point cloud data into a high-resolution 3D mesh, okay, which you can view as a surface here, as a surface mesh. And you see you will see in my live demo how the quality that we can get for this mesh. And then you can make your data completely, shareable, distributable. We do provide the technology for unlimited users. So now we have about 20,000 users using the platform over the last 2 years. And these are not only expert surveyors. And this is one of the cool features, which is a comparison feature between the as-built conditions on the BIM model or the CAD model, be able to detect issues visually and document those issues, and then be able to interoperate with your BIM platforms. So this is really what Cintoo Cloud is about. And now we are working on all other aspects like asset management, VR, AI, and things like that. So this is just the beginning. So we do serve most laser scanning industries, being BIM and construction. This is where we started from, coming from Autodesk. But we also serve the industry 4.0. So we have a lot of customers in car manufacturing, in energy, in oil and gas. They all love the platform, and we're expanding mostly based on the word of mouth, since we could not make any marketing over the last 24 months. So there's basically 3 types of value propositions coming with the platform. The first one on the left-hand side is everything collaboration and sharing for your laser scan data. And now we're also expanding not only to terrestrial scans, but also mobile scans on drone data as well. So by having this mesh-based viewer, we do allow a very easy interpretation, navigation, interpretation. Of course, you can enrich with measurements, annotations. We can distribute the data back as a mesh or as a point cloud. This is really what people would subscribe to the platform for first initially. Everything in the middle is around visual analysis, so quality control. How can you compare your as-built conditions to the design intent and easily document this? And this works only for construction site, but also not only for construction sites, but also for all kinds of other places like factories, plants, or rigs. And last but not least, on the right-hand side, we are now moving into what we call asset management. We are capable of extracting all kinds of information, including equipment, location, and orientation, bounding boxes, and things like that, using AI. And then you can use this platform to create 3D dashboard for your asset management workflow. But we can speak about that later. So the way it works, before moving to the demo, we will take the laser scan data as a registered data. We don't do the registration. The registration is done in Pharocene, Recap Pro, Leica Cyclone, Register 360, etc. We will take your register scan. We will do the point cloud to mesh transformation. Everything in the cloud is mesh-based. We will connect Cintoo Cloud to other BIM platforms, and you can distribute the data to go to your favorite CAD application. But let me go into more details. So the way it works, we'll take your RCP, E57, or FLS files. We will run locally on your machine this point cloud to mesh transformation. It takes about 1 minute per 10 million points. So if you have laser scans of 10 million points, it will take about 1 minute to do this point cloud to mesh transformation. And then we will automatically upload the data to Cintoo Cloud. So everything uploaded in the cloud is mesh-based. If you need to distribute the data back on the desktop, like for Revit or AutoCAD or Navisworks, we will do also locally the inverse transformation, mesh to point cloud, so that you can retrieve either E57, RCP, or CS files to feed your Revit or Navisworks or AutoCAD platforms. We can also export and download mesh-based data, being FBX, OBJ, STL. Of course, you will be able to export issues in BCF files, measurements, annotation. You can also share. Connecting to BIM 360, we'll be able to pull a BIM model, being an IFC, a Navisworks, or a Revit model. We will be then overlaying the BIM model to the scan data in our viewer to be able to detect differences. And then you can push back those issues, reports, and analysis back to BIM 360 again, or BIMTrack or Procore. Okay? So as you understand, it's all about streaming high-resolution 3D meshes in a WebGL browser. That works for desktop, laptops, tablets, but also works also now for VR engines or game engines like Unity or Unreal. And if you come to the booth today, we have a booth up there. You will see a demo where we stream live mesh-based data into Unreal, and we display that on the stereoscopic display using our good friends at Silverdraft, providing the VR headset. So again, please come to the booth. You'll be able to experience this mesh-based viewing of your scanned data in a headset. So Cintoo is still a small company. We have been in business for about 2.5 years, but growing very fast. The technology took about 10 years to be developed. There has been 1.3 million scans uploaded to the platform, which is about 2 billion square feet of laser scan data, which is pretty sizable. And let me go through a quick demo of the platform now. So here I'm using Google Chrome. It could be also Microsoft Edge, Mozilla Firefox. See, this is my list of projects, which I can view on a map like that. Or I can also view on a list. Okay? When you create a project, you can select, as I said, you can select the data center where the data will be hosted. You can select, I want my data to be on Amazon in the US or on Azure in Europe. It's just your call. Okay? And let me show you an interesting project here. This is a courtesy of SSOE in the US. They did this renovation of the former Martin Luther King Elementary School. On here, we have, you see, this is still a small project with about 471 scans, but we also have other layers of information. We have a BIM model here, we have a 2D drawings, we have a lot of stuff. And you see, one of the cool features of Cintoo is the way you can organize your data into various subfolders, which we call work zone. So this is the scan data that's been spread, scans have been spread over various work zones. Let me look at this one, for example. In this work zone, you have 21 scans. I can, let me find another set of scans here. Let's take this one as an example. So this is a typical scan. This is a Faro scan, 10 million points. But what we did with this technology, we turned that into a 3D mesh. So when I go into the 3D view now, I will be streaming this high-resolution 3D mesh. So what you see looks like a panoramic image, but this is a 3D mesh model. Okay, so if I remove the color here, you will see the surface that has been captured by your laser beam, which will reveal details in your laser scan that you have probably never seen before. And this is all about streaming meshes, okay? So let's move to the next vantage point, like this one. You will see the streaming happening until you get the finest level of detail. And even if I zoom in, I will be streaming even more levels of details until I get the full resolution of the scanner, okay? So this is really the core technology. Of course, I can apply the RGB. I can also show that with intensity, but also I can apply a heat map here that will, along the Z-axis, will allow me to check, quickly check for, floor flatness. Very easy using a mesh-based viewer to create those kind of heat maps, And this is what the technology can do for you. Let me go back to the surface mode here. You will use this kind of view to make very accurate measurements. So you have various ways to do measurements. You can constrain your measurements by some axis, like being X, Y, Z, or do a freehand. And you see, using a mesh, you know exactly which points you are picking, And this makes your measurements much more accurate. When we save a measurement, we save it with a context, so whoever will be coming back to this project will be able to see your exact measurements, you see? You can also use this kind of view to create annotations. I click on the 3D point here. This can be a node, can be a private node, can be an issue. But let me come back to this one a little later. What you can do as well is navigate your space in the 3D space. So you see here I selected only one work zone, which is a gym level 1, okay? But now let me add more scan data. Let me add the outside of it. You see? Let me add gym level 2, gym level 1, and we have a very cool shader here, which is called the X-ray vision mode. With X-ray vision, you can see through the walls, see your scan layout, You can use this kind of view to take a top view, go to the orthographic mode, zoom in, okay, and add more layers of information. So this is your side view now, see it from the front. Let me add more scans here. Let me add all the scans all together. And now I can also decide, in addition to my scan data, you see how fast we stream about 500 scans. Okay, if you were to open 500 scans in Recap today, you probably can grab a few coffees. Okay? And I know it's my product, it was my product formerly, But anyway, and now I can add the CAD model as well. You see how fast we do that? And now you can also add the 2D drawings. Okay? And again, if I select one of the vantage points here, let me go to X-ray vision to select the right vantage points. I'm looking for this, probably this one, yeah, okay? So here from this exact vantage point, let me go back to the RGB mode. I can see, or let me move to this one, it's more, okay? Here from this exact vantage point, I can see scan on BIM. I can move to the surface mode, and I can use this comparison tool here to say, I want to compare my scan data to my models, okay, use this visual check tool, and by using the transparency slider, I can see this is the exact existing conditions, okay, and you see again the mesh quality we have here. On moving my slider to the right, I can see the mesh plus the BIM model or the CAD model, okay? Let me go and use another project now, which has been provided to us by our good friends at True Point Laser Scanning. Should be here. This one is interesting as well. This is a smaller project, only 100 scans. With some customers, we have seen projects that include 9,000 scans. 9,000 scans in a single project. This is really huge. With this project, we have various layers of information as well, including what we call a sitemap. So a sitemap will allow you to put the project in the context, being a Google Earth view or something like that. But let me show you. So let me start by displaying the east side. We have 24 scans here, okay, that are streamed here very fast. Let me switch to surface mode again. Let me do some backface culling. With backface culling, you can do really cool stuff because you can see the inside from any angle. So because everything we do is mesh-based, okay, what we do with backface culling, we don't display the polygons that are not oriented towards my camera. So from any angle, I can see the inside, okay, which is pretty cool. Now I can say I want to add my 2D drawing, for example. So this is 2D drawing plus scan. I can add more scans. And already by having scan on 2D, you can do some analysis. You go to the top view, go to orthographic camera. Let's switch to the X-ray vision mode. And here you can see all kinds of information. For example, you see this pillar is not exactly aligned to the exact as-built conditions. I know there is an issue here. You see this iframe here is pretty well in place, but you can have all kinds of information. And I know there is an issue here. One of the doors, let me find it. This is the one. You see, this door here in the 2D drawing is not aligned to the real door. That can be a real issue. But let me go into this one with another method. So here I've got, again, scan plus 2D. Let me switch back to surface mode or even RGB. Those scans don't have RGB, so no, meaningless. But let me add now the BIM model as well. So now I'm adding the BIM model. Okay, so go back to my scan view here. So what I see from this exact vantage point is scan plus BIM. Okay, and what people do with the platform, they do what we call a visual check. So they go into the comparison tool. I want to compare my scans to my models. Okay, and I have another tool here, which is a visual diff tool. Automatically here, we create a heat map based on the differences between scan and BIM. And I can adjust the tolerance I want. So here I'm creating a heat map that will be adjusted, could be feet as well, to 0.3 feet, basically. So everything in green is a good match between your BIM and your as-built conditions. Everything red is data that is in the as-built conditions, but not in the BIM model. So, for example, you see this door here is off by 1 foot. Let me go and check that using the visual check tool. You put the slider on the left, you see the as-built conditions, okay? And you see again the mesh quality you have here. And you put your slider on the right, you see that the door is off by 1 foot, okay? And this is a kind of important information that you need to document. So what you will do next, you'll go to the annotation tool, you add a 3D point here, call it an issue, give it a title, this door off by, okay, needs to be replaced. You can add labels, because at some point, some people here are creating like thousands of issues per project. So you need to be able to add labels to filter those issues. You can add a severity parameter, a due date, add text, photo, video, hyperlink to your issue here. You can also assign it to a team member. We have a lot of features around user management. How can you manage access to your scan data or your BIM models? And you can also limit the access to one of those work zones that you see on the left-hand side. So let me assign it to, let's say, my colleague Alex here. I validate that he's part of this work zone. And then I create the annotation. So the annotation has been created here, which I can see in the report tab. This is a list of all my annotations or measurements. This is the one I just created, okay, which I can play 3D again. And these are all the annotations that have been, or the issues that have been created before that. So what do I do with this information? I can export it as a PDF, okay? This PDF will contain hyperlinks so that you can send it by email, and people will click on the hyperlinks and will be opening Cintoo Cloud. You can export them as BCF, which Brett mentioned earlier today with Revisto. This is a BIM collaboration format. This is an XML file that will be able, that you can read in Revisto, but also in Navisworks or Revit. Or what we do is that also we connect cloud to cloud. With Cintoo Cloud, we connect with BIMtrack, BIM360, of course, and also now Procore. So what you do here, you will push those annotations to one of those platforms to link those annotations with your BIM coordination platform, okay? So this is the kind of workflow people are using daily with this platform. I did mention that we have a lot of features around users and permissions. When you have here at the top your directory of users, which you can group per groups. And when you invite one user or a group to a project, you will give him or her a given role that comes with permissions. So for example, a BIM manager can do almost everything on a project, but you could create a role which is viewer only, okay? In which case, the person will be able to view only. So what you do when you go into a project, first thing you would do, you invite your team members. Let me go to the same project here. Okay, so either I invite those users at the root of the project, so when I go into members here, they will be invited to see all the subfolders. Okay, so when I add a member, I will add my colleague Alex here. On this project, I will tell him, on this project, you will have the role of a view only. Okay, and this is how I'm gonna invite you to this project. or I can invite other people to a work zone only, in which case those contractors, for example, will be able to see only this work zone. Okay. So there are so many other features that we don't have time to show today, but I'm open for a few questions if you have any now. Thank you very much for your attention.